Welcome you all to the second lecture series on applications of derivatives. So in this video segment we shall solve all the problems given in the exercise 6.1. I hope you have gone through the first lecture where we have in brief seen what are the different applications of derivatives. So we got to know that the applications of derivatives can be classified into 5 main categories, and the first one happens to be to find the rate of change of different quantities. So here in exercise 6.1 we shall be solving all the problems where all the problems deal with the first category, where we talk about the rate of change of a given quantity. So let's go ahead with the first problem. The first problem states that we need to find the rate of change of the area of a circle with respect to r when the radius is 3 centimeters and b when the radius is 4 centimeters. Right? So we know that the area of a circle is given by pi r square. Okay? So whenever such a problem is given, write the expression for the area here, because we need to find the area of the circle, and differentiate the area with respect to r. So here it becomes 2 pi into r. Okay? So now I need to find the rate of change of area with respect to r when r equals 3 centimeters and when r equals 4 centimeters. Okay, so what do? Substitute the value of r. So if I substitute r equal to 3 centimeters, so what do I get? I get 6 pi. And if I substitute r equal to 4, I get 2 into 4, which is equal to 8 pi. Okay, so this is the rate of change of area with respect to So this is the rate of change of area with respect to the radius. So what about the units? Rate of change of area. So area is in centimeters square with respect to the radius r, which is centimeter. So similarly here this is centimeter square divided by centimeter. Okay? A very simple problem. So let's move on with the second one, where the volume of the cube is increasing. So the volume of the cube is increasing at the rate of 8 centimeter cube per second. Now how fast is the surface area increasing? So the surface area, how fast is it increasing when the length of the edge is 12 centimeters? So in the second problem, it's been given that the volume of the cube is increasing at the rate of 8 centimeter cube per second, and we need to find the increase of the surface area if the side x equals 12 centimeters. So we know that when we consider a cube, all the sides are equal, isn't it? Right? So this is a cube, all the sides are equal, so this is x, and now we know that volume equals x cube. So now let me differentiate this with respect to t. So dv by dt is 3x square dx by dt. So this can be written as dv by dx into dx by dt. So I've skipped a step. Now this is equal to 8. Right? Now given surface area. Now what is surface area of a cube? The surface area of the cube is 6x square. There are 6 sides. The surface area of one side is x square. So it's going to be 6x square. So what is ds by dt? So ds by dt equals 12x into dx by dt. Right? So we need to find ds by dt. But what is unknown? The unknown value is dx by dt. So from this, what is dx by dt? So we get, so from this expression, dx by dt equals 8 by 3x square. So let's substitute this value here. So I get 12x into dx by dt is 8 by 3x square. Right? So x gets cancelled. So here this becomes 4. So here this is 8 into 4 is 32 divided by x. So ds by dt, the rate of increase of the surface area is 32 by x. But I need to find the increase when x is equal to 12. So for x equal to 12 centimeters. So therefore ds by dt equals 32 by 12. So what is the answer we get? So the answer which we get is equal. So 4 8s are 4 threes are, so it's going to be 8 by 3 centimeters square per second. So this happens to be the rate of increase of surface area when the side of the cube equals 12 centimeters. A very simple problem. So now let's move on with the next one. So the third one states that the radius of the circle is increasing at the rate of 3 centimeter per second. Find the rate at which the area of the circle is increasing when r equals 10 centimeters. So given dr by dt equals 3 centimeter per second. So it's been given that the radius of the circle is increasing at the rate of 3 centimeter per second, and we need to find the rate of change of area of the circle when r equals 10 centimeters. Okay, so I need to find dA by dt. So we know that area of the circle is pi r square, right? So if I differentiate dA by dt, I get 2 pi r into dr by dt, right? So I need to find dA by dt for r equal to 10. So therefore 2 into pi into r is 10 into dr by dt is given, which is 3. Okay, so we get 60 pi centimeter square per second. So this happens to be the rate of change of area of the circle when the rate of change of radius is 3 centimeter per second and the radius is 10 centimeters. Okay, so we have seen that the problems are pretty simple. So let's move on with the next problem, the fourth problem. Given that the edge of the cube is increasing at the rate of 3 centimeter per second. So we know that a cube, all the sides are equal, so let the side be x. So given dx by dt equals 3 centimeter per second. Now how fast is the volume of the cube increasing? So I need to find dv by dt when the edge is 10 centimeter long, right? So when x is 10 centimeters, I need to find dv by dt. Okay, so here we know that the volume equals x cube. So therefore dv by dt equals 3x square dx by dt. That is known here. So now I need to find dv by dt when x is equal to 10. And we also know that dx by dt is 3. So let me substitute. So 3 into 10 square into dx by dt is 3. So this is 900 centimeter cube per second. So very simple problem. Let's move on with the next one. 5. A stone is dropped in a lake and the waves move at 5 centimeter per second. When the radius is 8 centimeter, how fast is the area enclosed increasing? Alright, so here a stone is dropped in a water body. So when a stone is dropped, the waves move circularly, and it's been given that the waves move at the rate of 5 centimeter per second. So when the waves are moving, it basically means the radius is increasing. So dr by dt is 5 centimeter per second, and I need to find the rate of increase of area. So this actually becomes a problem of a circle. So area of a circle is pi r square. So therefore dA by dt equals 2 pi r dr by dt. So I need to find dA by dt when r equals 8. So when r is equal to 8. So therefore I have 2 pi, so this is equal to 2 into pi into r is 8 into dr by dt is given, which is 5. So I get 80 pi centimeters square per second. So that's the answer, a very simple problem. Now problem 6, the radius of the circle is increasing at the rate of, so dr by dt is increasing at the rate of 0.7 centimeter per second. Now what is the rate of increase of its circumference? So we know that the circumference is given by, so let me call this a c, it's given by 2 pi r. Okay, so I basically need to find dc by dt, which is equal to 2 pi into dr by dt. So it is 2 pi, dr by dt is given, which is 0.7. So this becomes 1.4 pi centimeter per second. So we realize that it's such a simple problem here where the circumference expression is known. It's been given that the rate of increase of the radius is 0.7 centimeter per second. So therefore just consider the expression c equals 2 pi r. Differentiate this with respect to t and you get the final answer. Okay, we just have to substitute for dr by dt and we get the final answer, which is 1.4 pi centimeter per second. Right? So we realize that all the problems here are so simple and easy. Let's move on with the next one, which is very easy. The length x of a rectangle is decreasing. So let the length be called as x. So that is decreasing at the rate of 5 centimeter per minute. And the width y is increasing at the rate of 4 centimeter per minute. Now if x equals 8 centimeter and you have the value of y, which is 6 centimeter, find the rate of change of part A, perimeter, and the area of the rectangle. So perimeter and B, the area of the rectangle. Okay, so what is the perimeter? So this is a rectangle. So this is x and this is y. So perimeter is 2 into x plus y. Alright, so therefore dp by dt equals 2 into dx by dt plus dy by dt. So I am differentiating x and y with respect to t. Now given that the rate of change of length, which is decreasing, so therefore dx by dt is negative and y, the width is increasing, so this will be positive. So I have 2 into, so this becomes negative here and this becomes positive. So I have minus 5 plus 4, so I get minus 2. So here centimeter per minute. So what is happening? The perimeter is actually reducing at the rate of minus 2 centimeter per minute. But what about the area? The area is x into y. So I differentiate this with respect to t. So dA by dt equals x into dy by dt plus y into dx by dt. Now what about x and y? X and y is given here, which is 8 and 6. So let me substitute those values. So x is 8, dy by dt is 4, y is 6, but dx by dt is minus 5. So I put a minus sign here into 5. Okay, so 8 into 4 is 32, minus 6 into 5 is 30, so I get 2 centimeters square per minute. Okay, so this happens to be the rate of change of area of the rectangle. So it is 2 centimeter per minute. So problem 8, a balloon which is spherical is being inflated by pumping in 900 cubic centimeter of gas. So cubic centimeter of gas per second. So find the rate at which the radius is increasing when r equals 15 centimeters. So again a very simple problem. So here you have a balloon which is spherical, which is being inflated. So we know that the volume of a sphere is 4 by 3 pi r cubed. So the volume is 4 by 3 pi r cubed. Okay, so if I differentiate this with respect to t, I get 4 by 3 into pi into 3r square dr by dt. Alright, so now what is being given here? So it's been given that dv by dt is 900. Okay, so that's the air which is actually being pumped into the balloon. Okay, so now dv by dt is 900, so this is equal to 900. Okay, so now I need to find the rate at which the radius is increasing. So I need to find dr by dt. So what is dr? So 3 and 3 gets cancelled here. So dr by dt is 900 divided by 4 into pi into r square. So I need to find dr by dt when r is 15. So substitute the value of r equals 15. So this is 900 divided by 4 into pi into 15 square. Okay. So when I do that, what do I get? So this is 900 and this also becomes 900 into pi, right? So 15 square is 225 and 4 gives me 900. So I get the value as 1 by pi centimeter per second. Okay, so the rate of increase of the radius is 1 by pi centimeter per second. So problem 9 states that a balloon which is always spherical has a variable radius, right? So here you have a balloon which is spherical, so the volume is definitely 4 by 3 pi r cube. And since it has been mentioned that the variable is radius, so we have to differentiate v with respect to r, so that is known. So find the rate at which the volume is increasing. So I need to find the rate at which volume is increasing, that is dv by dr, when the radius is 10 centimeters. So when r equals 10 centimeters. So if I differentiate this dv by dr, so I get 4 by 3 pi into 3 r square. So this 3 and 3 gets cancelled. So I substitute r equal to 10. So I get 4 into pi into 100. So it is 400 pi centimeter cube per centimeter. Okay. So this is the answer. So next, problem 10 is a very interesting problem. So it states that a ladder 5 meter long is leaning against a wall. So this is a wall and this is the ground, and here we have a ladder and the length of the ladder is 5 meters. So this is 5 meters. Okay. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. Okay. So we are actually pulling the ladder away from the wall, from the bottom of the ladder, and the rate at which we are pulling it is 2 centimeter per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? So I need to find out how fast the height of the ladder is reducing when the foot of the ladder, when this distance is 4 meters. Now we have a ladder which is inclined onto a wall and this is the ground, and we observe that this is nothing but a right angled triangle. So I can consider this to be ABC, right? So we have, if this is Z and if this is X and this is Y, so we know that X square plus Y square equals Z square. So from the figure here, we know that X square plus Y square equals Z square. And what is Z? Z is 5, so this is 25. Okay? And also, we find that the rate at which the ladder is being pulled from the bottom is 2 centimeter per second. So we know that dy by dt. So dy by dt is given, which is 2 centimeter per second. So now I need to find dx by dt. So now let me differentiate this. So I have 2x dx by dt plus 2y dy by dt equals 0. So what do I need to find? I need to find dx by dt, and all the other values are actually known here. So now from this expression 2 can be cancelled and dy by dt is 2. So I have x into dx by dt equals minus y dy by dt is 2 here. Okay. So now it's been given that I need to find dx by dt when y is 4 centimeters. So can we find the value of x when y is 4 centimeters? Yes, it's possible because z is fixed, z is 5. So therefore, I have 25 equals, so when y is 4, y square is 16 plus x square. So x square is 25 minus 16, which is 9. So therefore, x is equal to it was root 9, which is 3. Okay, so therefore x is 3 and y is 4. So what do I get? So we have dx by dt, which is minus y. Y is 4 into 2, which is minus 8, divided by x is 3 centimeter per second. So the rate at which the height of the ladder is decreasing is 8 by 3 centimeter per second. So this minus sign here indicates that this is decreasing. So either we say that the height of the ladder is decreasing at the rate of 8 by 3 centimeter per second, or we say that dx by dt is minus 8 by 3 centimeter per second. So the sign indicates that it is reducing. So problem 11 states that a particle moves along the curve. The curve is 6y equals x cubed plus 2. So find the points of the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Right? So the y coordinate is changing 8 times as fast as the x coordinate. So what does this mean? So let us consider this expression here. So the y coordinate is changing 8 times as fast as the x coordinate, right? So therefore dy by dx equals 8. So now let me differentiate this expression with respect to x. So I have 6 dy by dx equals 3x square plus 0 here. So now dy by dx is 8, so I substitute the value here. So this implies 6 into 8 is 48 equals 3x square. Okay, so I get 16, or this implies x square equals 16, so x is equal to plus minus 4. Right? So now I need to find the point on the curve. So the value of x can either be plus 4 or it can either be minus 4. So when the value of x is equal to 4, what happens? So when x is 4, we have 6y, so I need to calculate the value of y. So 6y equals 64 plus 2. So this is nothing but 6y equals 66, or y equals 66 by 6, which is 11. So one of the point happens to be 4 comma 11. So this is x and this is y. And when x is minus 4, I get 6y equals minus 64 plus 2, which is nothing but 6y equals minus 62. Right? So we get the value of y as, so this can be divided by 2. So this is 3 and this is 31. So y becomes minus 31 by 3. So therefore the value of x is minus 4 and the value of y is minus 31 by 3. Right? So these are the 2 points. Next, problem 12. The radius of an air bubble is increasing at the rate of, so dr by dt is 1 by 2 centimeter per second. At what rate is the volume of the bubble increasing when r equals 1 centimeter? So the radius of the air bubble is increasing. So when we talk about an air bubble, we assume that it is spherical. So therefore the volume is 4 by 3 pi r cube. Okay, so now dr by dt is known, which is half centimeter per second. So let me differentiate v with respect to t. So dv by dt equals 4 by 3 into pi into 3r square dr by dt. Alright, so now this 3 gets cancelled. Dr by dt is 1 by 2 and r is 1. So I substitute the value of r equals 1. So we get 4 pi into 1 square into 1 by 2, which is 2 pi centimeter cube per second. Right? So the rate of change of volume is 2 pi centimeter cube per second. So very easy problem. Next, problem 13 also is very simple. A balloon has a diameter, which is, so the diameter is 3 by 2 into 2x plus 1. Right? Find the rate of change of its volume with respect to x. So I need to find the rate of change of volume with respect to x. So since a balloon has been given, we assume that the balloon is spherical. Okay, and the diameter has been given as 3 by 2, 2x plus 1. And we know that the volume is 4 by 3 pi r cube. So everything is with respect to the radius. And what is diameter? Diameter is twice the radius, isn't it? So therefore, if I consider the radius, it's going to be 3 by 4 2x plus 1. So if I divide the diameter by 2, I get the radius. So the radius is 3 by 4 2x plus 1. So let me substitute the value of radius here. So I have volume equals 4 by 3 pi into r. Now this is r. So 4 by 3 2x plus 1 the whole cube. Alright. So now I need to differentiate this with respect to x. Okay. So now what happens? So let me take the cube here. So I have 4 by 3 into pi into 3 cube by 4 cube. And this is of course 2x plus 1 the whole cube. Right? So this gets cancelled. So I get 3 square by 4 square into pi. So what is 3 square? It is 9. 4 square is 16 into pi. 2x plus 1 the whole cube is what I have. Okay. So now let me differentiate this with respect to x. So when I differentiate this with respect to x, so dv by dx is 9 by 16 pi. So I have 3 into 2x plus 1 the whole square into 2. So finally what do I get? So here 2, 8, so this becomes 27. So finally I get 27 by 8 pi 2x plus 1 the whole square. So this is dv by dx. So we actually had to find the rate of change of volume with respect to x. So we have actually found out dv by dx given by this expression, which is 27 by 8 into pi 2x plus 1 the whole square. So problem 14 is very interesting. So there's a pipe and sand is being poured from a pipe, and as the sand falls it takes the shape of a cone, right? So the sand is being poured from a pipe at the rate of 12 centimeter cube per second. The sand falling forms a cone on the ground such that the height of the cone is, so it's been given that the sand is falling from the pipe and it takes the shape of a cone, and the height of the cone is 1/6 the radius of the base, right? So now let's assume that y be the height and let x be the radius of the base. So it's been given that the height of the cone is 1/6 the radius of the base, or I have x equals 6y. Okay, so therefore the radius of the base is actually 6 times the height. Now the question is, how fast is the height of the sand increasing when the height is 4 centimeters? So when the height is 4 centimeters, we would like to find out how fast is the height of the sand increasing, right? So when we talk about the height of the sand, it basically means the height of the cone. So how fast is it increasing is the question. So now we know that the volume of the cone is actually 1 by 3 pi x square into y, right? Where x happens to be the radius of the base of the cone and y happens to be the height. So this formula you need to remember. The volume of a cone is 1 by 3 pi x square y. So this is known. So from this what can I do? I know that x is 6y. So let me substitute this here. So 1 by 3 into pi into 36y cube. So the volume now can be represented in terms of y, which is the height, which is nothing but 36 pi y cube. So let me cancel it out. So we get 12 pi into y cube, right? So now let me differentiate the volume with respect to y. So I get 12 pi into 3y squared. So I get 36 pi y squared. So what is being asked? We need to find the rate of change of the height. So I need to find dy by dt. Okay, but I found out the change of volume of the cone with respect to the height, which is 36 pi y square. Alright, now what is being given? It's being given that the sand is being poured from the pipe at the rate of 12 centimeter cube per second. So what is this 12 centimeter cube per second? So this actually indicates the rate of change of volume of the cone, isn't it? So dV by dt is 12 centimeter cube per second. Alright, so now I need to find out dy by dt. Okay, so now this can be written as, so dV by dt can be written as dV by dy into dy by dt. Right? So dV by dt is known, which is 12. So this is 12. So this implies the LHS is 12 equals dV by dy. So which is 36 pi y square into dy by dt. So what is it that I need to find? I actually need to find dy by dt when the height is 4. So when y equals 4 centimeters. Right? So this is 3 times. So I have 1 by pi into 3 into y square, which is 4 square, which is 16, equals dy by dt. Okay, so dy by dt is now 16 into 3, which is 48 pi centimeter per second. Right? So we wanted to know how fast the height of the sand is increasing. The height of the cone is increasing. So it is increasing at the rate of 1 by 48 pi centimeter per second. So problem 15, the cost C of x in rupees associated with the production of x units of an item is given by, so C of x equals 0.007 x cube minus 0.003 x square plus 15x plus 4000. So the question is, find the marginal cost when 17 units are being produced. Right? So when x is 17, I need to find dcx by dx. So d of cx by dx is nothing but 3 into 0.007 x square minus 0.003 into 2x plus 15. So wherever x is there, we just have to substitute it by 17. Okay, so here I have, so this is going to be into 17 square. So this is going to be into 17. Alright, so now what do I get? So finally we get the value as, so the answer is 20.97 rupees. Okay, so similarly problem 16. Problem 16 states that the total revenue in rupees received from the sale of x units of a product is R of x equals 13x square plus 26x plus 15. And we need to find the marginal revenue when x equals 7. So this is a very simple problem where I differentiate dr of x by dx, so which is 26x plus 26, and put the value of x equal to 7. Alright, so when I do that, I get, so what is the final answer we get? The final answer what we get is rupees 208. Right, so you have 26x plus 26, so it's going to be 26 into 7 plus 26, which gives me a value 208. So next we have two multiple choice. They're very interesting and very simple though. The rate of change of the area with respect to the radius at r equal to 6 centimeters is. So we know that the area of a circle is pi r square, isn't it? So what is dA by dr? So dA by dr is 2 pi r. Okay, so now r is 6. So I substitute the value of r equals 6. So therefore I get 12 pi. Okay, so where is 12 pi? We search all of them. So here A is 10 pi, B is 12 pi, C is 8 pi and d is 11 pi. So the right answer is B, which is 12 pi. So B is the right answer, which corresponds to 12 pi. So again from 18, the total revenue in rupees received from the sales of X units of a product is, so R of X is 3x square plus 36x plus 5. So we need to find the marginal revenue when X is 15. Now such problems are very easy, you just have to differentiate and substitute the value of X here. Okay, so there are 4 options. So let's first calculate. So dr of x by dx is 6x plus 36. I need to put the value of x as 15. Alright, so when I put the value of x as 15, what do I get? So it is 90 plus 36, so I get 126, right? So you have 4 options, 116, B is 96, C is 90 and D is 126. So the right option is D, which is 126. So in exercise 6.1, all the problems were such that we had to find the rate of change of quantities. And this happens to be one of the most important application of derivatives. So in each and every problem we had to find the rate of change of a particular quantity, and we did that successfully by just differentiating it. So we also realized that the problems are very simple, okay, and this happens to be one of the most important application of derivatives. I hope you have gone through the first lecture and you have also solved all the problems given in the exercise 6.1, and in all the upcoming lectures we shall see the various other applications of derivatives. So do not forget to like, share and subscribe, and press the bell icon to get notifications of further uploads, and thanks for watching.